JJ, suppose that I have a random variable that is normally distributed, and I square it. What's the distribution of that squared normal?
ChiSquared.
Perfect. The answer was chi-squared. So if you have a random variable and you square it, you get a chi-square with 1 degree of freedom. If you have a whole collection of normal random variables, you square each one of them and then add them up. You get a chi-square with whatever number of terms are in the sum. Explain to us the difference between a central and a non-central chi-square. I'll ask you a different question, because we only have 2 more minutes. I better make it a brief question, huh? When you took statistics as an undergraduate, you were still writing on clay tablets then. But when you took statistics as an undergraduate, you did something with hypothesis testing, correct? And maybe in the very beginning, you tested a hypothesis that the mean was equal to 0 against the alternate hypothesis that the mean of a distribution was equal to 1. So you had a very simple alternate. Why did hypothesis testing work in that framework? Oh, and first of all, what sample statistic did you use to test a hypothesis about the population mean? You used the sample mean, right?
Yes.
So you used the sample mean to test a hypothesis about the population mean. And we said the population mean is 0 under the null against the alternate, that it's 1. And because we knew that the underlying distribution was normal, we could just use a z-score, right? And why were we pretty confident that that testing framework was going to work?
We just assumed the distribution.
Well, under the null hypothesis, our sample statistic rather, the sample mean, was centered at the origin. Under the alternate hypothesis, it was centered at 1, quite different. So that the normal distribution, which is our z statistic, was either centered at 0 or it was centered at 1. So the distribution of the sample statistic looked much different under the null than it did under the alternate. Then as you grew up, as the weeks went by in that first statistics class, you then started to use t-statistics. And where they were centered changed depending on which hypothesis was correct, the null or the alternate. And what you didn't learn about then was that when the alternate was true, there was something critical about the denominator of that t-statistic which was changing also. How do we construct a t-statistic, by the way? Out of what 2 underlying distributions do we construct a student's t-distribution? It's the ratio of a normal to a chi-square. So we're going to pick up here next week. We're going to talk about chi-square and f, and why it's of interest to us to understand non-central chi-square and non-central f. You might look them up on Wikipedia, by the way. How many of you have ever had linear algebra before? Almost everybody. How many of you have ever had kind of an intermediate level statistics class? Math stat? Not too many. But some of them, okay.